just need to be doing the homework. You're not going to be able to get through the exam. You will have wasted this whole year if you don't do the homework and know how to do use substitutions. You don't want to do that. You need to be doing this. Same with the differential equations. We need to separate these variables. So I'm going to multiply through by dx. Maybe. dy is equal to cosine of x times e to the y plus the sine of x dx. And you notice that we have x's on the right side because the differential tells you what variable we want to have here. So we want this and we want that. And I have to know some algebra to be able to separate that. If you've noticed, you can only separate problems that are in that are multiplication. If they're addition, you can't separate those. So, and you're going to say, well, I can't separate that. But yes, I can. Because this is dy, and this is the algebra that's getting us in trouble here, times e to the y times e to the sine of x. I can't integrate it until I get rid of all the y's that are on the wrong side. Now, the question is, do you recognize what I just did right here? This is properties of exponents. Think about it going this direction. What would you do with the exponents since the bases are the same? You'd add them. So the cosine of x is fine, the sine of x is fine, the problem is e to the y. So let's divide by e to the y. And you get a point for separating them. Now they can be almost as complicated as this. You have some examples. This is number 7 out of the homework on 6-4. But we're going to do a u substitution to the right-hand side of this anyway. So it was a good question to ask. Now remember, everything has to look like that blue worksheet with all the integrals on it. Everything has to look like that. There are no other integrals that we know. So I'm going to have dy over e to the y. Some of you are going to say, well, that's log. That is not log. The log is 1 over x dx. It has to look like 1 over x. It can't be 1 over e to the x. You see the difference there? It has to look just like that. And then this is the cosine of x, e to the sine of x, dx. And we're going to do a u substitution because I don't see what that is going to be either. And so we're going to find the antiderivative of both sides. So I would like to change, well, I might have to do a u substitution on this. I'm hoping, well, if you practice, I think you could do it without the u substitution. I don't like that e in the denominator, so let's put it in the numerator. So it's e to the minus y dy equals cosine of x times e to the sine of x. Now, guess and check is perfectly okay. What's the antiderivative of this one? That's the side. What if it were just e to the y? It'd be e to the y. So what if it's e to the minus y? Let's check it. What's the derivative of e to the minus y? You could do a u substitution. I don't think it's necessary. That would be e to the minus y times what? Negative 1. Well, I don't have a negative 1, so what do we have to do to fix this? No, not a 1 over. That doesn't change the sign. It's negative. Now does it work? If you take the derivative of e to the minus y, you get e to the minus y times the derivative of minus y, which is negative 1, which will cancel that negative 1. I could put c on this side. I could put them all over there, so I'm going to put them all on the right. Doesn't really matter. Now, this is the one you might need a u substitution for. What I'm looking for in a u substitution is I'm looking for a composite function, and I want the u to be the inside of the composite function. What do you want u to be? Sine of x. This is in the inside. It doesn't look like it is, but it is. If u is equal to the sine of x, then what's du? Cosine of x. And the only way you get better at this is to practice. Honestly, that's what you've got to do. So the cosine of x dx can be replaced by just a simple du. So I'm going to end up with the integral. That's going to be du. And then e to the sine of x is e to the u. Right? Oh, I know how to do that. Do you know how to do that? It's e to the u plus c, because you get your point. Your third point is adding the c. You can go no further. Now we've got another problem. I got to get rid of the u. That's one thing. And I got to solve for y, because what's a differential equation? It's an equation which involves derivatives and whose solution is a function. You have to know that by next Tuesday. So you have a little bit of work to do over the weekend if you haven't been doing your work. What's antiderivative of e to the u? E to the u. I could plus C1 plus C2, and then I'm going to put all my constants on the right side. I'm going to change this back. What was u? Sine of x, right? And then let's make this C, where C is equal to C2 minus C1. It's just a number. I don't really care what it is, because I can't find it. I don't have an initial condition. Now, I want to solve for y. Before I can log that, because that's how I get rid of the exponentials, what would I have to do first? I want to solve for y. What do I have to get rid of? What's the negative in front is a problem. So I'm going to divide by a negative or multiply by a -1, however you want to look at it. And so I get e to the minus y equals e to the sine of x minus c, or if you make it another constant, a, who cares? We don't really care. Oops, thank you. I missed a negative sign there. And then now what are we going to do? Yeah, go. What are you going to do now? How do you get rid of the exponent, the exponential? What's the opposite of this? Log. And this is going to be a log of the side. Can I distribute that? No. So what's this going to give you? Negative y. I think I did that right. Math isn't bad, but you have to know the rules. So I can't distribute that. Negative e to the sine of x minus c. Hopefully, what? It's negative y, isn't it? Okay, and then so what's y equal to? It's equal to the negative log of this. And I wouldn't bother much more with that than what I'm doing. There are things you can do with log properties, but who cares? So I just did a little u substitution. But we can go back into 6.2, and if you have, I can just pick problems. They may be out of the homework, they may not, I don't know. But I can just look at them and say, oh, we need to know how to do that problem. Oh yeah, we skipped 6.3 because that was integration by parts. We don't have to do that. I know I did 33. I don't know if I did it in this class. We could do 41. That's a nice little one. And would anybody like to know how to integrate the tangent? I don't know. It's one of these problems. I know that. So I want the integral of the tangent of x dx. Well, first I'm going to write that tangent as what? No, that's the derivative of it. I'm not going to do u substitution yet. It's sine of x over cosine of x. And you're saying, well, that didn't do me any good. Now I'm going to do u substitution because that still doesn't look like, and I could have the list up here, it doesn't look like the power rule. It doesn't look like any of the trig things. So I'll do u. What do you want u to be? Sine of x. Then du is equal to cosine of x dx. So if I try to do that, I'm going to have u, and I'm going to have cosine of x, and dx, if I solve for that, would be du over cosine of x. That didn't look like it got me anywhere. Okay, Adam? So what's a better choice for you? It didn't get me anywhere. It's not like it's not wrong. It just didn't get me anywhere. So let's try u equal to the cosine of x. Then what's du? Negative sine of x dx. Okay, I think I've got everything accounted for, don't I? I have a sine of x dx. What is sine of x dx? It's what? It's not du, it's opposite of du. So I got minus, and I've got a du there, and the cosine of x we let be u. Anybody recognize what that one is? If you don't like the way that looks, we can rewrite it as this. 1 over u du. It's one of the, I don't know, what are there, 10 you have to know? You don't have to know the tangent one. They're not going to ask you this one, but what is that? Natural log. Do you need absolute value? Yes. Plus C and U was the cosine, especially since the cosine can be negative. And if you look up in the integral table, and I don't know where my Math CRC book is, but the page, there are probably that many pages in a Math CRC tables in terms of integrals that you just look up, because who wants to do them again? Somebody's already done them. There's lots of tricks and things you can do. We're just doing a simple little U substitution. Some people can just look at those and see what's going to happen. A U substitution is just a little trick to help you see it. I don't know what problem that was, but it was one of these. And a problem like, well, if you have your book open, 42, we wouldn't have anything like that. Ooh, I like 39. 55 we've done. Twice. Oh. What did we? Oh, we did the we did differential equations. So I can do that, but there's also video.
All you did was
yeah, well, I did the PERT one. Let's do one more of the U substitutions. Let's do 39. Then I'm going to review that because it's so important.
we learned how, where, we learned how we learned how to become an alcoholic.
Okay, you guys, what are you going to do with that one? I'm looking for a function, and I'm looking for its derivative. Maybe if I wrote it this way, it would be easier for you to see. Is that the same thing? Yes. Artavan, do you believe that those are the same things? So I'm looking for a function. I see its derivative there. What's the derivative of 1 over x? No, that's the integral. Okay, we should know how to do the derivative of this. This equals x to the negative 1 is negative 1 x to the negative 2. So it's negative 1 over x squared. So I don't want u to be 1 over x because that doesn't work. If I let u equal x, that doesn't do anything. It doesn't change anything. So how about ln of x? Because what is the derivative of that? That's 1 over x dx. There's only so many that can be done. Yeah, if they could have made it so you couldn't do it. If this had been ln of x squared, I'd still do the same U substitution. Vastly different results. Okay, so this is, together is a du. And this is 1 over u. Oh. What is that one? The log of the absolute value of u. I didn't. U is equal to the log of x. U equal to x wouldn't change anything. That's the log of x. And so then it's the natural log of the absolute value of the natural log of x. Can the natural log be negative? Yes. What does a natural log look like? What's true about the log of 1/3? A little review of logs. This is the log of 1 minus the log of 3. What's the log of 1? 0. So when you do the log of a fraction, it's minus the log of the whole number if it's reciprocal. That's kind of cool. Which really helps a lot, actually. Question over here? Right. That's why you get some strange answers. Where it looks like you're going to get a negative and you can't have it, but the log of a fraction, these are all fractions in here. Logs of fractions are negative. More U substitutions or review? Yeah, PERT. Huh? This is a log. This is the log of the log. That's a number, and then that's another number. That's going to almost look horizontal, because the log function grows really slowly. You can do the log of the log. Log of x is just a number. What if x is equal to e? What is this then? It's the log of the log of e. What's the log of e? 1. Log of 1 is 0. Okay. For the benefit of the seniors and for those who weren't quite here yesterday. Now, Ardavan. And the reason why I'm going to hit on this again is because this is really important. They say well, you have it in your notes from 6-4, but you have the notes for it. You have the notes, so I gave you all the packets from before. And it says that the population, the rate of change of the population is directly proportional, which means it's a multiple of the population. You will see this on the multiple choice section of the exam. That's a guarantee. There are 10 questions that are repeated every year on multiple choice. And from what I can see on the multiple choice that I can see, that question in some form or another is on the exam. Okay, you guys? So we're just going to solve this equation. I wouldn't memorize it. It's PERT, but I wouldn't memorize it because all you have to do is cross multiply. This is K, P times dt. And how do we solve that? What do we have to do next? Right, can't have the letters mixed up here, the P and the T. So we're going to divide by P, because that undoes that. Do we recognize this yet? This is K dt. What's the left side? It's the log, right? And I guarantee you're going to see logs on this exam. More logs and exponentials, and I know you don't like them, but they're heavy on the exam. So this is the log of the absolute value of P. Now, because this is population can't be negative. But you have to be careful, because if it's just a regular problem with logs in it, you could have negatives, and we do have to worry about that. So this is K times what? T. And then what do you have to put in now? Plus C. If you don't put the C in now, you're in big trouble. You may solve for P and then say, oh, I forgot to put C in and add it in later. That's just plain wrong. Has to go in right after you integrate. Okay, now what do I do? Now what do I do next? I have to exponentiate each side. Ardavan, side. You can't make that e to the kt plus e to the c. This is the problem I've graded. I saw that a lot. Nope, you can't do that. Don't try to simplify. This is the absolute value of p is equal to e to the kt plus c. Okay, we said this was positive. P is greater than 0. So P is equal to e to the kt times e to the c. If you're going to do BC Calc next year, Calc 2, wherever you are, you need to know your properties of exponents. Okay? That question? Is that okay? Calc 2. Right. Anybody who gets 3, 4, or 5, depending on the school. Some schools don't accept any of the AP results. Some will accept even a 2 and give you college credit. Madison does that. But a lot of places won't give you college credit for a 3. If you're getting a 3 and you're going to like a big school like Minnesota, I'd repeat the class. Yeah, if you're going to Minnesota or Madison. Big schools, big classes, teachers that don't really care about the students. That's not what they're there for. They're there for research. So, okay, guys, if you go to a small school, it's not a problem. If you get a 5 on the exam, I wouldn't repeat the class. Okay, you guys, this is just a constant. E is 2.7 to some number. I don't know. So why don't we just call that A? Now, shh, you guys, girls, when t is equal to 0, let's say my population is p sub 0. My initial population. I could have used p sub I. So I'm going to substitute this in for p. So p sub 0 equals a times e to the k times 0. What's a equal to? P sub 0. Does this look familiar? You might have seen it this way. That's PERT. It's at 159. Okay, let's look at the parachute problem. There's a typo on there. Now, the other thing you should be looking at would be looking at the Chapter 6 review packet. That's also good preparation for your test. Give you a feel for what's on there. This quiz is strictly a skill quiz. Can you find the antiderivatives? If you need, use substitutions, or if you don't need them. But let's look at the parachute problem. I like this problem, but it was question number 6, I don't know, 1997 or something like that. And nobody got 9 points. On the back of the waste problem. So what we did in class yesterday was we did the waste problem, but they're not that different. Oh, yeah, I have to get it for you. -2b. I'm going to need it too because I don't think I remember it. Now, there's a typo on there. So it's not an inequality, it's equals. My mistake. Why do I have so many of these? Oh. What time is this stuff? 1:59. There you go. Seniors, raise your hand. Or if you were gone yesterday, it really doesn't matter. Guys going to the game? Oh, you got that one. I hope that's right, because that's all I got. Okay, we don't have a lot of time, but let's get this started. Oh, there we go. Okay. I'm out. I don't know why I'm out, but I'm out. Hey, guys. But if Matt's going to do that to his, we could give you his. Let's double check. I'll get you another one for Mrs. Hersman, but right now, there's not much there to do anyway. Okay, guys. Okay, shh. Adam, what am I going to do? I can't. You always have to separate the variables. No, I'm going to multiply by dt, which is going to give me this. Now be careful. And that was a fatal mistake. Don't do that. Factor out the -2. It's easier to leave the constant on the other side. Remember the waste problem that we did? It was dw dt, which is PERT, by the way, 1/25, and it was okay. This is PERT, you guys. It's dw dt equals some constant times w. Oh, that's not a big deal. It just kind of tags along. It's the same thing. That was the waste problem. And some of you wanted to move the 25 to the left side. I said, trust me, it's easier if you leave the constant there and just get the v part. This looks just like the waste problem. The only constant that's here is -2. Instead of W minus 300, it's V plus 16. Did I do that right? And so what do we do now? I got to get what? I got to get rid of something here. Okay, guys. Divide by what? V plus 16. Now, nobody should have probably done, well, I assigned it, but that doesn't mean you did it. So I have this. dV over V plus 16 Ardavan equals -2 dt. So what is the antiderivative of 1 over V plus 16? This is where it's critical to have your absolute value, by the way. Can't split it, it's plus. It's just fine. Would you like to do a U substitution? It's the natural log of V plus 16, isn't it? Now, if you had this, if you had the 2 over there, you have to deal with that 2 and worry about a U substitution. This one, I don't have to because it's just 1, so it's nice. Equals -2 what? T plus C. And then it gives me an initial condition. Thank goodness, because I'd rather do it that way. It's what? Is it at T equals 0, it's -50? Okay, substitute it in here. Do you see why I have to have the absolute value, Ardavan and Matt? It's the log of the absolute value of -50 plus 16 equals -2 times 0 plus C. What's C equal to? What does that give us? 34? So C is equal to the log of 34. Put it back in your equation, which is right here. I'll have to slide it a little bit. So actually, I'll write it up over here. It's the log of the absolute value of V plus 16 equals -2t plus the log of 34. That's exactly like what I just did, isn't it? We did it in the waste problem yesterday. We did it with PERT yesterday. It's still the same thing. Okay, we have different letters. Who cares? What are you going to do now? Okay, guys? It's not easy. So now, what's going to happen here when I do this e to the log of the absolute value of V plus 16? Adam, shh. Absolute value, if you're talking, please don't. If you're not interested, I guess it's your problem. And this is e to the -2t. Yeah, but you know what? You tell me tomorrow, do I want the plus or do I want the minus? Don't assume.